Hello everybody, this is Odd Job Entertainment bringing you another video. Today we're going to talk about Newtonian physics in Star Citizen. Now this isn't going to cover everything, and it will be at a low level, so don't worry if you don't have a physics degree. Now of course, to make a game fun, you have to make a few compromises on the physics side. So am I surprised there's weird things? No. This is just supposed to be a fun point of discussion and possibly a solution to some problems that we don't quite face yet. Anyway, according to Newton, force equals mass times acceleration. So anytime a force is applied to some mass, it will accelerate. So the classic dad joke while doing a push-up of, "I'm not doing a push-up, I'm pushing the world down," well, it's technically true as long as you actually get off the ground. This also means that anytime a mass has a force applied, it will accelerate. So when you're on a plane, the force of the engine will accelerate the plane until the force of air resistance equals that of the engine. At that point, it can't go any faster. Remember, we're talking acceleration, not velocity. The plane has already reached a high velocity at that point, but can no longer accelerate to go any faster. But there's no air in space, so there's no air resistance. There's also no speed limit. In fact, the only thing that really determines the top speed in space is the fuel efficiency and carrying capacity of your spacecraft and the speed of light. The fastest spacecraft we've ever made as a species so far, for instance, is the Parker Solar Probe at 430,000 miles per hour, or 192,227.2 meters per second. So if you think your Gladius feels fast, that's almost 200 times faster. Now in Star Citizen, ships have a maximum speed. They have a max speed for thrusters and while in quantum. And that brings us to our little science experiment for today. Because how fast can you get from place to place if those speed limits weren't in place? How fast could you go if your ship continued to accelerate until it had to slow down? So as we run through the numbers, we're going to use the much beloved Gladius. According to the RSI website, the Gladius has a forward acceleration of 118.5 meters per second squared and a top speed of 1,235 meters per second. Now my own testing suggests there are some discrepancies here, but we kind of just need a number for our mental game here, and the actual values are always subject to change anyway, so we really just need ballpark figures. And of course, the slowdown does take quite a bit longer than the forward acceleration, but we're also going to assume those values are the same in order to keep things simple. And we're also going to assume an infinite hydrogen tank and quantum tank as well. With all of that said, how long would an ideal trip from Crusader to Hurston take? In order to solve this, we take the distance between the two planets, divide it by 2, and calculate the time it takes to travel that distance with constant acceleration. So 32 million kilometers divided by 2 is 16 million kilometers. Using the kinematic equations of motion to solve for time, we find that it takes 16,432.9 seconds to span half the distance. We then multiply that by 2 to account for the deceleration part of the trip, and we find that it takes 32,865.9 seconds to get all the way there, or 447.7 minutes, or 9.12 hours. Now that doesn't sound very impressive until you throw in the max speed limitations we currently have in game. That math is a lot easier to calculate since the acceleration time is negligible, so we just take the distance and divide it by the max speed. So 32 million kilometers divided by 1,235 meters per second for 25,910,931 seconds, or 431,842 minutes, or 7,197 hours, or 300 days. And on screen now is the numbers for how long it would take to get from Microtech to ArcCorp. Now where this gets really exciting is when we switch gears to quantum travel times. Our Gladius is equipped with a VK00 quantum drive, and using Urkel.games, we can get the travel times directly. It takes 4 minutes and 34 seconds to get from Crusader to Hurston, and 6 minutes and 9 seconds to get from Microtech to ArcCorp. To keep things simple, we're going to ignore the difference between stage 1 and stage 2 acceleration. We'll be using the stage 2 acceleration for our calculations. As it turns out, when traveling in quantum, We already spend much of the time accelerating and decelerating. We can see this in two ways. First, if we just take the distance divided by the max speed of our drive, we see that the travel time with instant acceleration is much shorter than our actual time. The other way we can see this is that the time under constant acceleration isn't that much faster than what we already get. We shave a minute off of our time from Crusader to Hurston and 2 minutes of our time from Microtech to ArcCorp. But we are on the verge of getting access to Pyro, and from what we know, distances in Pyro might be much longer than what we have in Stanton. And when future systems get put into place, it could get even bigger than that. That would mean that we spend much more time watching pretty colors streak across the screen. Now, how big of systems should we expect? Or how big of distances should we anticipate traveling at quantum travel speeds? Well, we don't really know yet, but we can already see that if Pyro has distances that are just 2 times the size, we might not want to have that top speed in place. If you look at this graph that takes things to an extreme, you can see that the larger the distance, the more the gap increases in sense of time. If we want to keep travel times tolerable, I think the answer, at least in quantum travel terms, is instead of a max speed, just list drives by efficiency and max acceleration. Now the tricky thing here is that distance and time are used as balancing mechanics. We don't have any kind of instant fast travel in the game because it invalidates that mechanic. Larger vessels, for instance, are able to store more quantum fuel and therefore require fewer stops to get from point A to point B. There are different drives with different efficiencies and speeds. All of this to say that CIG have made a game where travel time means something. But I don't think my suggestion hurts that or works against it. Even in the shorter distances, however, my change of removing top speed from a quantum drive does allow ships to travel at a velocity greater than the speed of light. Granted, it is a game, and the lore can be written however many ways to justify that, but at shorter distances the benefit of that is marginal at best. And just look at the times that we discussed earlier. Now these are the kinds of ranges you would expect to be traveling if you're a combat pilot, tracking down bounties or causing trouble to attract the hunters yourself. It's only at the larger ranges that the change becomes more apparent. And what kinds of ships will be traveling these distances? Well, explorers and traders for the most part. Now while CIG have talked about adding more ways to interrupt QT via debris, interdictions, part breakdowns, etc., there will still be a good amount of time spent watching rainbow streaks on your screen. But by removing the top speed of quantum drives, that time can be reduced. Distance and time will still have meaning, but it would be curtailed to prevent player burnout. Anyway, I hope you enjoyed that foray into some of the physics of Star Citizen. Like, share, comment, subscribe, do all the YouTube things, and until next time, this is Odd Job Entertainment, signing off.